level, a high level would work perfectly. Okay, there's some issue with the phrasing. From our food basket, we collect data like size, color, weight, skin type, shape, etc. from all our fruits. After collecting the data, we start making classification. If the size is big, color is red, the shape is rounded with a depression at the top, and the bottom is the top and the bottom, put it in set 1. If the skin type is smooth or shiny on set 1 fruits, put it in set 2. Set 2 data can now be comfortably labeled as apples, as an apple will be put in an apple group. Okay, let's not dwell on this example. So they're just trying to show you how like you can get labeled data. You're saying, okay, these apples are like this, so these ones are fit in this category and these other ones fit in this category. Then you get a new fruit and you're like, okay, and then you train your data getting some features like color, weight, skin type, and shape, etc. You get a new apple and then say, okay, which category does it fit in? That's basically what they're trying to say. So let's go again, which was the whole point of this blog, to try to show you the real life business use cases for supervised learning. So supervised learning model makes prediction based on evidence in the presence of uncertainty. Some of the use cases for supervised learning are depicted below in the below picture. So it says examples are like people analytics, Internet of Things, info and cybersecurity, asset management, stock exchange, marketing and sales, healthcare, fintech. Yeah, so this is just a graphic showing you like IoT connected systems and devices for people life. Okay, you can analyze data that comes from IoT devices to make it like personalized or even market your devices and make it effective, really. People analytics could be like recommendations for sales and suggestions. I think this has something to do with marketing. Information security would be like credit card fraud, network security, email filtering. Asset management would be like asset maintenance, will be like logistic, outage and prediction, and systems capacity trends. So something like umeme here, like for electricity or even water. Utilities, really. You can just try to predict outages. You can try to predict like what is the system capacity, how are the trends of the system capacity. Marketing and sales, like sales performance, retention, and human resource management. So as long as you have data and you analyze, you have a real business problem and it is very uncertain how you can get trends from it or predict in the future what it will be, you can always use machine learning algorithms. Okay, so the main job of any machine learning algorithm is to analyze the training data as a first step. In the second step, deduce the function which can be used to depict new examples. So in short, the first step should be you train your data. The second step should be use this, you train your model with training data and then use this model on new examples. Okay, it has labeled data for creating predictive models by using either type of ML algorithm as shown below. It provides output typically in 1 or 2 forms. Okay, again, this is just repeating what we've just been saying. If you want to predict something that is continuous or numerical, you use the regression algorithms. If you want to predict something that is in discrete categories, you use the classification algorithm. So as shown above, problems under classification, binary here, they mean it can be like it's of 2 categories, or multi-class, it can be like more than 2. And regression comes under supervised learning. Some of these algorithms are mentioned below. All right, so these are the algorithms that you're going to start learning. So you see that this is linear regression, logistic regression, polynomial regression, support vector machines for regression, decision trees, random forests, support vector machines, naive Bayes. I've never known how to say these words. and then k-nearest neighbors. So these are just examples of these algorithms that we shall be learning. Okay? So focused use cases for supervised learning. Again, I think this is repeating what we've just been saying, like the different use cases, the different places where we can use machine learning in our day-to-day life or day-to-day businesses. So here we will focus mainly on 4 main problems that should be considered for supervised learning. In the use cases below, it is simple and easy to collect data, label the data, and make predictions with accuracy. So AI Lab page did a small survey among artificial intelligence experts to outline some facts around machine learning for personal use and blog sharing. While there were only 23 respondents out of 30 who voted to confirm what was evident already. Okay? So we are saying that the people analytics, it helps managers and executives make decisions about their employees and workforce, information and cybersecurity, protecting from unauthorized access by analyzing security event data using big data tools and technologies, fintech harnessing the power of big data, glean meaningful insights from many disparate data sets, and then healthcare analysis activities that can be undertaken as a result of data collected within the healthcare. Okay, so this is, I don't think I'll go deep into this. Still, they're just trying to reinforce the different use cases where you can use machine learning. So this is people analytics, information security, information and cyber security. You can see this says supervised learning in business, the common algorithms. So we are going to see these common algorithms. So you see like decision trees, go from observations about an item to conclusions. So since I'm going to share this blog, you can just go and read the particulars. But just at the whole point is just to show you in actual business environment, where can you use this supervised learning, this supervised machine learning. So we can see here information, people analytics, healthcare, and I think these are also limited. There is much more. There is more examples, regression. You can see the crime rate, the amount of fraud, predicting housing prices. These are all things that you can do when you learn supervised machine learning. Yeah, and then this blog stops there. So far we've seen a simple introduction, supervised learning, what supervised learning is, a small introduction what unsupervised learning is. Under supervised learning, we've seen this classification and regression. Classification was to do with predicting categorical outputs, and then regression was something to do with predicting numerical or continuous outputs. And then now we saw the actual use cases of supervised learning in industry. So we've seen the different examples. And then also a high-level process of what you would go through when you're trying to use supervised learning. And then now we want to see the different algorithms. Okay. All right. So to recap, so far we've seen just a simple introduction to ML, what supervised machine learning is, and how regression and classifications comes in under that. And then we've seen the different applications in industry from where you can apply these supervised machine learning cases. And then we've also seen the process, the high-level process you go through. Okay. So now we shall just try and see if we can delve deep into the different actual algorithms, the popular ones at least. Yeah, okay. So let's follow through this blog post, and then after this we're going to see the Titanic competition example that was from Kaggle, and how they use the different algorithms, and the whole process they took. And then we shall also see how we can evaluate our models using another blog post. All right, so let's start. So a meticulous introduction to supervised learning in a simple way. Let's see how meticulous this is going to be. So in this article, we focus on the notion of supervised learning and its associated categories. In addition, we describe the components of supervised learning. Finally, we will briefly discuss the popular categories and algorithms without digging too much into detail. The goal is to have an idea of what supervised learning is, which is the whole goal of this process. All right, so this is just an introduction of what they're telling you, what the article has and what it doesn't have. We shall just go straight to the introduction. Let's just not go through the introduction. We already saw. You can read through that. And then what is supervised learning? This is what we've just delved out different. We just delved into in defining this in the different blogs that we just saw. And then now, here they say supervised learning process and algorithm selection. So before, we had looked at this as the supervised learning process, which is really sufficient for me, but they include extra steps here, just they break it down further, but really it just still falls under this supervised learning process, but we can go through it, okay? So here they say supervised machine learning consists of the following steps. So the first one is data acquisition. Determine the nature of the training data and perform data acquisition. Before any other step, the developer must decide what kind of data is to be employed and how to obtain it. For example, for face classification task, it may be a gallery of face images belonging to known individuals. For object detection, it may be a gallery of labeled images and the bounding object boxes for each object in the image. So this is really self-explanatory. The first step is always acquire the data. And then, so the second step is to pre-process the data. It's going to be a very popular word you hear, pre-processing. So this step is one of the essential elements of any machine learning modeling. And it's also notorious for being very time-consuming, as it is very clear from its name. This step aims to provide data for further processing and utilization. So data pre-processing or data processing refers to the acquisition and manipulation of data samples to extract and generate meaningful information. So before, in the previous process, we were calling this prepare your data. So sometimes, most times, all the times I should say, data is messy and you also want to understand what the data is, you want to clean it up, you want to prepare it for training. Okay, I guess they broke it down to the next step. So here they're saying data processing refers to acquisition and manipulation of data samples to extract and generate meaningful information. It includes different elements such as validation, assuring that the provided data is accurate and consistent. So doing things like validation, sorting, abstracting, only extracting and organizing necessary data elements, aggregations, combining various pieces of data, analysis, the arrangement, coordination, study, understanding, and the exhibition of data, and then classification, dividing it to multiple groups. Yeah, so like they say, data pre-processing is really going to be, it's going to be based on your use case. What do you want to do in the end? And how can you prepare your data to get ready for the model that is going to be trained on it? So data preparation, perhaps one way to classify data preparation step as a subset of data pre-processing. I also don't know why I think they're just trying to be very, very explicit, but this usually is just the same step. However, I decide to define a separate category for that to describe specific uniqueness in supervised learning. Here we must associate data instances to their corresponding labels as they're required by supervised learning. Okay, that's the reason I guess that they've split them out, trying to say that in supervised learning, we have to have labeled training data. So they're just using the data preparation step to associate data instances to their corresponding labels. So next, the data should be split into training and testing sets. Okay, so now we're going to go into the real steps of what you're going to do. So you've prepared your data, you've pre-processed your data, that's just trying to understand it, trying to look for, trying to validate it, trying to sort it, trying to look for like extreme cases, trying to get valuable data, and also trying to know like how does it look like and what are the features you're going to be using. So now, after that, we're going to split the data in training and testing sets. So the training set is supposed to be representative of the real world application. There are